This video is a tutorial about how to set up and manage monorepo with NPM Workspace and Git Submodule. There will be 4 sections. The first section is about initiating a monorepo. We will begin from an empty Git repository, then initiate some example projects and packages. I then set up NPM Workspace to link all the projects and packages together. The second section is about Git Submodule. I will use the Git Submodule command to clone to other repositories as submodules. Then I will show you how to link and manage them inside the monorepo. The third section is about managing package version and publishing. I will show you how to write NodeScript based on some NPM commands in order to pump package versions and dependencies. After that, we will publish those packages to a private NPM registry called Verdaccio. In the final section, we will set up Typescript and Jest to the monorepo. You can use the timestamp on the description to quickly navigate to each section. So let's initiate a monorepo. Here is an empty Git repository. I will initiate a root package.json using npm init. And assume that we have a React project. I will initiate it using Vite, npm create Vite latest. Let's name it web UI, and using the template React TS. This will quickly scaffold a React Typescript project. Next, assume that we have 2 other packages. I will create them using npm init workspace packages rd button. Don't forget to name the package with a namespace rd button, and the entry point will point to the button component. I will do the same with the other package, rd inputs. And here we have the 2 packages created. You can create these packages manually instead of using npm init command, but you have to make sure that the package has a package.json inside, and inside this package.json it has the name, start with the namespace, and the main field point to the main component. Now I will create the button component. It will export a very simple button. The button has an arbitrary text, and that's it. We'll back to the error later. I'll do the same with the input package. When I go to the package.json, you see that npm added a workspace field. In this field, specify the path to the 2 created workspaces. In order to specify that all directory inside packages are workspace, I will update it to packages / like this. And don't forget to specify web UI as workspace too. After update the workspace, I have to run npm install. This is to make sure that npm aware of our workspaces. Next, I want to specify that rd button is dependency of web UI. So I run npm install rd button. This is the name of the name we specify inside the package.json, and workspace web UI. I will also do the same with rd input. Now you see that rd button and rd input are listed in here as a dependency of web UI. Now if you check out the Node module, you see that all dependencies of our workspaces are installed and hoisted in here. But if any of our workspace has dependency with different version, then there should be a Node module directory inside that workspace. You also see our workspaces appear inside this Node module. Here is the rd packages, and they are syncing to the actual directory. This button is syncing to the actual directory in here. So it means that if you import a button component inside web UI, that button is actually this button component. I will show you right away. So I will open the app txx, and let's try to import the button. As you can see, Visual Studio Code already recognized the rd button as the dependency, and let's just remove this and render the button. If I go to the definition in here, it will redirect me to the actual button component. And let me test the web UI by running npm run dev. You can see that our button is rendered, and inside the button component, if I update it like this, this will reflect on the UI thanks to Vite that already support monorepo out of the box. So far, I think this is the most convenient way to test and develop Node package. If you want to create a Node library that want to test it on some project, let's set up a monorepo. Or if you have multiple projects that share some packages, you also need a monorepo. Besides NPM, you can use Yarn or NPM to achieve the similar workspace setup. Each tool have interesting features that the others don't have. However, I choose NPM for this tutorial because we can just have it up and run. If in the future you want the feature of Yarn or NPM, migrating the workspace to the other tool should be straightforward. Let me quickly commit the code. Init NPM Workspace. In this section, we'll learn about Git Submodule. Firstly, I would like to say that for the best scenario, we should have everything inside one repository. In that case, we don't need Git Submodule because it will add more complexity to your workflow. But for managerial or security reasons, we may have source code in many different repositories, and we will want to link them together. For example, you may have a project elsewhere that use our rd button, or maybe you have a package elsewhere that is a dependency of the web UI, and that package may sometimes be a third-party library. In either case, we can use Git Submodule to clone the other repository into our root repository. Then we can link them together using NPM Workspace. For example, I have these two repositories. This one, the Node server, is an example repo that use one of our packages, and the other one is a repo, an example of a package of the web UI, and it's also an example of a third party. In case it's a third party, then you have to fork it first before cloning. Now I will clone the Node server using Git Submodule add command. And you can see it cloning here, the Node server repository, and there is a .git modules. This file holds the information of the new submodule. I also do the same with use interval time, but I want it to be cloned inside the packages directory, so I will go in there and then run the Git Submodule add command. So now we can see that there is a Node server, the use interval time, and the Git module file is updated. I will run git commit to save the change. Node server use interval time. In this commit, you can see that Git will save the .git modules and the other two directory, Node server and use interval time. Git will not aware about the details inside each submodule. For example, if you go inside here and change something, like I will pump the packet version like this, and while still inside the root repository, if I run git status, it's just aware that there is modified content inside the submodule. And if I run git add in here, it basically didn't do anything. So in order to save the change inside the submodule, I have to go inside the directory, and I can see that this actual status of the repo, and then I can git add and git commit. Or if I want to create a new branch, I want to pull the code from the remote, I have to go inside the directory. The idea in here is basically you treat the submodule just like a regular Git repository. You can read more about Git Submodule in the homepage. I put the link in the description. Now back to our root repository. We need NPM to recognize the new submodule. So I will add them to the workspace inside the package.json at root. The use interval time is already inside the package directory, so it's already recognized as a workspace. Now I just want to add the Node server in here and run npm install again. Now you should see the use interval time symboling inside our Node module directory. The same with Node server symboling in here. The use interval time is a dependency of web UI and Node server, so I will install them using npm install use interval time and specify the workspace web UI and also another workspace Node server. Now if I go to the package.json of web UI, use interval time is listed as dependency, and the same in Node server. So to summarize, from NPM perspective, there are 5 workspaces: the Node server, 3 packages, and web UI. From Git perspective, there is 1 root repository, and there are 2 submodules, the Node server and use interval time. If you look into the setup of the use interval time, you see that it needs to be built. It has a build script in here. I will prepare a build script inside our root package.json. Let's call it build packages. This will run npm run build with the workspace packages. It specifies that it will run the build script of every workspace inside the directory packages. And then I will run it. build packages. It will throw the error inside RD button and RD input because there is no build script in these packages. So I will add another parameter, if present, and now it's only run the build script in the package that has the build script. So here is the tip. If possible, don't set up build script for the packages. Instead, try to set up the build tool in the web UI or the Node server to understand the package directly. In our current web UI, Vite can understand our RD button and RD input without further build step. If your web UI use Webpack, you can set it up to achieve the same. It will save us a lot of time since we don't have to wait for the package to be built, neither spending time to maintain the build script. In this section, we will learn about how to manage package versions and publishing. Before we begin, I already updated our monorepo a little bit. I already added 2 new packages, this RD command service and this RD utils. And I also installed these packages as dependency of other packages and submodule. Inside the web UI, we still use button and input as dependencies. However, I update the dependency version in here to asterisk. This means that we don't care about the version at all, because web UI and the packages live inside one repository. In fact, if you don't use Git Submodule or you don't want to publish your packages, then you can skip this section. Now, for the script that I'm about to introduce, first it will pump the version of all the RD packages, the version in here, and then it will search for the other affected workspace and pump the dependency version. Let's start to create a script. Let's call it upgrade packages. Because this is a NodeJS script, so it has to begin with a shebang. Node. Inside the script, it will run some NPM command. So I will require child process and get the execusing. This execusing will help us to run NPM or any command line. The first command line I want to run is npm query.workspace. This command returns an array of all the information of all of the workspace in our monorepo. Each item is actually an extension of the package.json. So I will copy it into our script to string and parts is to JSON. So now we have all the workspace. Let's log it to see if the code above is correct. And then I'll run the script. Create packages. It says permission denied because the script doesn't have executable permission yet. I will add it and then run again. Okay, so we have the workspace, and I want this script to update only the package that has RD namespace. So I want to filter them to name that starts with RD namespace and then run a loop. Inside each workspace, for example, RD button, I want to pump the version in here. To do that, I will use npm command called npm version patch. For now, let's just pump the patch version. It means that the last part, and I want to specify the workspace name. Okay. Also, I need another parameter, this one, because I don't want npm to update anything else except just the version. So I copy this into the script, excusing, and I update this into the current workspace name, new version. Notice that the result of this has 2 lines, so I will get the second line, split the second line, and I don't want to get the V, I only need this one, so slice one, and then let's lock this out. Space old version, new version, and then run the script again. There's a typo in here. Okay, so we pump RD button from 0.2 to 0.3. Let's see. The next thing is I want to find all the affected workspace and pump the dependency version. So let's call those affected workspace user workspaces. I'll find it. I filter all the workspace that has dependencies is the current workspace. Again, let's log this out. User workspace. Just log the name only. Map name. Okay, can read property of undefined. This is because some workspaces has empty dependency, so add an optional chain in here. Okay, so it lists that RDU2 is a dependency of RD button, RD command service, RD input, and node server. So I have to update dependency version of RDU2 in all of these user workspace. In order to do that, user workspace for each user workspace. In order to do that, I will use another NPM command called NPM pkg set. And for example, I want to update the RDU2s in here. I want to update this version of RDU2s. So I have to set the dependency.rdu2s equal to the new version that I want to update, like 0.9 for example, and specify the workspace RD button. Okay, so I will copy this into our script and update this into our current workspace name. Update this to the new version. Update this to the user workspace. So the package.json in here has asterisk version, which means that we don't want to manage the dependency version in here. So I will add a condition: if user workspace dot dependencies space name is not asterisk, then we will execute this. Updated user workspace. And let's run the script. Okay, something's wrong. This have to be the name of user workspace. Let's run this again. Okay, so now I expect that this user workspace has a new version of RDU2s. Okay, and the node server. Okay, so in the end of everything, I have to run npm install. This is to update the package log.json and also make sure that there is no syntax error. Let's run this again. Okay, I will save the script gray packages and commit it. And reset the rest. Before moving on, I would like to improve this script a little bit. Currently we hard-coded in here to only publish patch version. For example, I would like to upgrade to major or minor or a fixed version like this. I have to get the parameter version input. And in here, if version input is specified, we will use it. Otherwise, just pump the patch version by default. Let's test it. Okay. And I will reset the rest. Next, we will publish the packages to an NPM registry called Verdaccio. So Verdaccio is similar to NPM registry, but the difference is you can deploy Verdaccio on your private server, and it also serves as a cache proxy server between your local and NPM. For the demo, I will run it locally. npx Verdaccio, and that's it. We have the private NPM registry running at this address. Currently there is no package in this server yet. Before we publish the packages, I will config npm to use the new Verdaccio registry by adding npm rc file, and in here we will specify the registry to this address. And that's it. From now on, if I run any npm command, for example like npm install, it will get this will pull the dependency from this registry. So before we publish any package, we have to make sure that we already log in to the registry. We have to make sure that we already log into Verdaccio, and I will use the command npm who am I. Now if it doesn't throw error, it means I already logged in successfully. If you didn't do this, and you have to use npm add user and then register a new user and then use npm login to log into the server. In order to publish any package in here, we can just use this command npm publish and specify the workspace like rd button. Now I will refresh the home page and I see RD button is in here, but I won't do this manually. I will update our upgrade packages script. In order to do that for all the RD package in here, publish, and in here is we have the similar loop like this, and here we will run the npm publish, specify the workspace, and that's it. Before I run this script again, I have to remove this rd button by using npm unpublish force. Let's test the script. So that's it. All the packages are published to our private registry, and by this way you can install the packages in a separate context. For example, the node server or maybe use interval time can be run elsewhere in a separate context. For example, I already cloned node server repository to somewhere outside of the monorepo, and I will copy the npm rc so that in here we will use the Verdaccio registry, and I will run npm install. Now npm will pull the packages from Verdaccio server and install in here, and I can start a node server separately from the monorepo. Before we dive into setting up Typescript and Jest, let's recap where we are in our monorepo setup. We currently have 7 workspaces, node server, 5 packages, and the web UI. In this section, we will set up Typescript and Jest for these workspaces. Keep in mind that the process of setting up these tools may vary depending on your project's specific requirements, and it can take some time. But nonetheless, I do hope that this tutorial will provide you a good start. So let's set up Typescript. Inside the web UI, we already have the tsconfig.json. This file is generated by Git, and I will use it for the root repository. I also have to install the Typescript as dev dependency for root. And make sure that it has the same version with the web UI. Okay. Inside the tsconfig.json, I will update the include field to include all of the source directory. And for the references, this will help to improve the speed of type checking. But in our monorepo, we go with the approach that we skip the build tool for most of the packages. So I will remove this. And to make sure that the tsconfig.json inside web UI is consistent with the tsconfig at root, I will remove this one and use extends to extend the config from root. Okay. For the node server, because this is a separate repository, so I will then clone the tsconfig into the node server. and also install Typescript for the workspace. In here, I will just remove the TXX configuration. Okay. Now let's open the button component, for example. Now Visual Studio Code should use the tsconfig at root for this file. If it doesn't, then you should restart Visual Studio Code, or you can just restart the TS server. Now I will try to build the web GUI, and you can see that the build script will show the error that consistent with the error of Visual Studio Code. I will fix this very quick by adding a button type, button prop type. Okay. This is a typo, sorry for this. And that's it, the error goes away. Next, we will set up Jest for unit test. In the previous tutorial, we already have a Jest configuration for use interval time package. It is this file. Now I will copy it to our root repository. And also I have to copy all the dev dependency related to Jest to in here to the root. I have a newer version Typescript. I will keep the new one and remove the roll up, remove the React. I will do the same for Node server, but in here the test environment for the Node server should be Node instead of JS DOM. The test match look good. For the package.json, we will have the dev dependency in here. Now I will run npm install again. So currently we have one Jest config at root and one Jest config inside Node server and another one inside use interval time. I want to run the Jest command at root, and in order to make sure that Jest recognize the other two Jest config, I will then use the config projects. For the Jest configuration at root, I will use the project like this, and this project is an array. Each item is either a Jest configuration or a path to a project that has its own Jest config. For example, I will add the path to Node server in here and the path to the use interval time package. And the last project is a Jest configuration. I put this one inside here. For the test match, let's say that we want to test every source directory that had the file .tsx, either ts or tsx. And for this project, we have to ignore all the test case of Node server and use interval time. So I will add test path ignore patterns. Put these two paths in here. In order to run the test, I will have to update the test script in here to use Jest. Okay, we nearly done, but before running tests, I will then prepare some test case. Inside Node server, I already have the main.test.ts. This test case is a very simple test case for Node environment. Let's create a test for the RD button. In order to test React component, we will use React testing library. I'll just copy the code example. Let's remove this one, import the button, and for this test we will test the button to should render without crash. Okay, let's create another one for WebGUI. In here we will have a test case for the app component, and the test case is similar to the button. That's it. Now let's try to run the tests for all of the workspaces. Okay, we can see that the main.test.ts is passed. The test inside use interval time also passed the button. But for the app.test, we are having issue with import CSS. Let's try to fix that. Inside the jest.config, we have to update the config for this third project. And in order to make Jest ignore this issue, I will use a config module name mapper. This is the home page of Jest, and we will use this pattern. But for CSS, so for import the CSS file, we will map it to a mock file. For example, a mock file will be mockstyle.js, and I will create that file. Okay, let's run the test again. And that's it. We already set up Typescript and Jest for our monorepo. This tutorial ends here. Thank you for watching and follow through, and see you in the next tutorial. Goodbye.